Well, it's this time of the year again. It's time to goof around with the Arduino. If you haven't watched my previous video, please do so. And be sure to hit that like and subscribe button, am I right? Okay, let's get into the video. First I had to disassemble my first project, and after around 10 minutes I've already disassembled and organized everything. Since I haven't told you guys yet, today I'll be working with sensors.
So this right here is a sensor. What I basically want to achieve here is I want to make this LED right here go on when an object crosses the ultrasonic sensor or ultrasound. I don't know.
It's ultrasonic.
And yeah.
So what we want to do is when some kind of object crosses the ultrasonic sensor, it like explodes or something. So for this project, I needed some jumper wires, an ultrasonic sensor, an LED light, breadboard, an Arduino, a mouse, some orange juice, Instacook noodles as well. I needed a chair, this little funny skeleton guy as well, cause why the hell not? And a huge amount of testosterone, of course. So as always, we need to first import all of our components and basically say where they'll be connected to on the Arduino. We have an LED 1, a trig pin, and an echo pin. The LED is assigned to 13, the trig pin to 10, and the echo to 11. Next we configure the trig pins and output, and then the echo pins and input. But why do we set those two things to input and output? First, the trig pin outputs a sound wave into the random object. When the sound wave bounces back into the echo pin, we get the time taken to do so, then we can deduce what kind of distance it was. All of that is then sent to the Arduino. So next in the code we have I don't know what that does, to be honest. Anyways, what I do know, however, is that the pulse-in command that's assigned to the duration variable essentially measures the time for the sound wave to return to the echo pin. The serial print just outputs the distance into the console. Then there's a simple if and else statement. If the distance is smaller or equal to 5, so if there's an object in front of the sensor, then the LED will light up. If that's not the case, the LED will remain unlit. So now, as we can observe on the sensor, there will be a place to connect the ground, echo, trig, and VCC. The ground will just be the ground pin, echo and trig will be the echo and trig pin, and the VCC will basically be the power. Let's start connecting the components. First, I connected the ground. Then I connected the trig and echo to pins 10 and 11, how we said on code. Finally, there was the VCC pin, which I connected to 5 volts. So before connecting the LED, I decided to test the sensor out, and as we said in the code right here, it outputs the distance from the nearby objects. If I move my hand close to it, it changes to a lower value. The only thing left to connect was the LED, which I connected similar to the one in the first video. Let's test it out. This is it from me for today, so next video I'll upload on the Arduino will be on some servo motors that I bought, so stay tuned.